Hi all, hope you all are doing good. From today onwards, we are going to see a lecture series on the subject Design and Analysis of Algorithm. Please note down the course code. It is 19 ITB 201. B represents blender, so it is a blended course. So first unit is Introduction to Algorithms.
Hi, now we are going to say about mathematical analysis of recursive algorithm. What do you mean by recursive algorithm is the algorithm that calls itself for the functioning. It's called recursive algorithms. In the previous videos, we saw about non-recursive algorithms. Now we are going to see about the analysis of recursive algorithms. So this is the general plan for analyzing the time efficiency of recursive algorithm. The first step is we have to decide on the parameter as such the non-recursive algorithm. So we're going to concentrate on input size in the first step. Second step, we have to identify the algorithm's basic operation. Third one, check whether the number of times the basic operation executed. It can vary upon different inputs of same size. If it can, the worst case, average case and best case efficiencies must be investigated separately. The fourth step is set up a recurrence relation with an appropriate initial condition for the number of times the basic operation is executed. In step 5, we have to solve the recurrence relation, or at least ascertain the order of growth of its solution. So let's see an example for the recursive algorithm. So the best example for analyzing of recursive algorithm is factorial of a given number. Now we are going to analyze the example factorial of a given number. What do you mean by factorial is the n factorial, which is equal to 1 up to n minus 1 into n. So up to n, for example, if we consider 5 factorial, we have to multiply 5 into 4 into 3 into 2 into 1 for n greater than or equal to 1. So this is the basic process in computing the factorial of a given number. The algorithm of the factorial computation is given by f of n, where we are going to compute the n factorial recursively. Here the input must be a non-negative integer, which is represented by n. Next, the output is the value of n factorial. So if n is equal to 0, we have to return 1, that is the factorial of 0 is 1, else we have to return the factorial, that is f of n minus 1 into n. So here the recursion comes. So the recursion in this problem comes here, f of n minus 1 into n. So now we have to find the initial condition and the terminating condition. For the factorial of given number is given by f of n, which is equal to f of n minus 1 into n for n greater than 0. So number of multiplication, that is recurrence relation, is given by the equation m of n is equal to m of n minus 1 plus 1. What is m of n minus 1 is to compute f of n minus 1, that is the plus 1 we are going to represent as to multiply f of n minus 1 by n for n greater than 0. So here the initial condition sequence is, if n is equal to 0, we have to return 1. If n is equal to 0, no multiplication of or done, so m of 0 is equal to 0. Next, f of n is equal to f of n minus 1 into n. So we are going to substitute all the previous identified conditions using the backward substitution method, and finally we are going to arrive at the equation m of n is equal to m of n minus I plus I. If we substitute n instead of I, the equation becomes m of n is equal to m of n minus 1 plus 0, which is equal to m of 0 plus 1 n. M of 0, which is represented by the initial condition, the value is 0. So 0 plus n is, the final equation is n. So m of n is equal to n. So this is the analysis of the factorial of a given number.